I'm going to spend a little bit of this afternoon, it's November 7th, working on ramp problems. And the ramp problem that we're going to spend our time with here this afternoon will or can be applied to any type of ramp problem that you might solve in the future. So we'll first start out with imagining that we have a block or a brick that's sitting on a ramp, and the ramp subtends this angle theta with the flat surface. And first step is always drawing a force diagram. So the force diagram, of course, has force gravity, which is pulling the brick down towards the center of the Earth, and force normal, which will be perpendicular or normal to the ramp angle. So there's a right angle between the ramp and force normal. It's common misconception that students have is to draw force normal as opposite of force gravity when it is not the case. So force normal is always perpendicular to the force, or perpendicular to the ramp angle itself. So, and then the third force that's associated with this brick that has now gone away is the force of static friction, or Fs. Well, that being said, my next step in the solving any problem would be to define the x and y axis. And so I'll start out with the x-axis, and I like to solve these problems with the x-axis being parallel to the surface and the y-axis perpendicular to the surface. And the reason for that is that allows for both the force of static friction in this case and force normal to be only in the x and or y direction, where if I was to solve this problem from the perspective of doing an x and y axis that would be horizontal and vertical, then only force gravity would not need to be resolved. And so in this case, I only need to resolve force gravity into its x and y components. So let's start out there. I'll start out by drawing force of gravity in the y direction. So there's force gravity in the y direction, and here is force gravity in the x direction. And we can immediately say, now that we've drawn those two forces, we can immediately say that force gravity in the x direction and Fs will be equal to each other, and they'll add up to 0 because of Newton's first law. So Fs plus Fg in the x direction equals 0. And we can also say that force normal and force gravity in the y direction equals 0. Because the brick isn't accelerating, or at least in this example, it's not accelerating. It's either could be moving at a constant velocity, or actually, since it's static friction, it must be at rest. So, next step, I've solved that problem. My next problem is to make a triangle that I can use to do with trigonometry, and I'm going to draw the triangle like so. So there is my triangle, and the right angle is as such, and the triangle needs to have a hypotenuse, and so the hypotenuse is force gravity. That means the adjacent side will be force gravity in the y direction, and the opposite side will be force gravity in the x direction. So if I'd like to know what's force gravity in the x direction, I can use the angle here. This angle will be 90 minus theta. and or this angle here, and this angle will be theta. Since I've already defined the sides, adjacent, hypotenuse, and opposite, I should go with my theta angle. Okay. Next, then, will be to say that we know that cosine theta will be equal to force gravity in the y direction over force gravity. And so that means that force gravity in the y direction equals cosine theta times force gravity. In the x direction, it will be similar, except we'll be using sines instead of cosines. So we have sine theta will be equal to fg in the x direction over fg, or fg in the x direction equals sine theta times fg. So this tutorial here will help you solve any sort of problem that would occur, or at least get started with any problem that has to do with ramps, whether it's sliding or not. If it's sliding at a constant velocity, then instead of fs, it'll be fk being equal to fg in the x. If it has an acceleration down the ramp, then of course fs, or I'm sorry, fk in that case, and fg in the x direction won't equal 0, but they will equal some amount of force, and you can determine that force and then thereby determine the acceleration. And that's what we'll be doing in the next unit. Thank you for listening.